Implementing efficient dynamic programming algorithms is more of an art rather than just programming technique. It involves identifying if a problem can be solved using dynamic programming, then formulating a recursive formula, and then applying dynamic programming techniques to implement efficient algorithms which are scalable to handle even large amounts of data. That's one of the reasons dynamic programming problems are most commonly asked questions in coding interviews. It tests your problem solving skills. But if you ask anyone who is preparing for interviews which are the most difficult type of problems in coding interviews, the answer is most likely going to be dynamic programming problems. Dynamic programming has a lot of practical applications too. It is widely used in artificial intelligence and machine learning algorithms, for example, speech recognition. Dynamic programming is also used in optimal control systems which are used in spacecrafts, robotics, and also autonomous driving. And dynamic programming is not only useful in computer science but other areas as well, such as bioinformatics, financial analysis, operation research, supply chain management, etc. Like any skill, dynamic programming also requires a lot of practice to be able to come up with efficient algorithms from scratch, especially if you have not seen the problem before. It doesn't really help much if you just know the solutions to few popular dynamic programming problems. That's why I have designed this course for anyone who want to understand dynamic programming in depth and learn some important tools and tricks to master this art of dynamic programming quickly. Once you understand the underlying concepts and step-by-step approach to implement dynamic programming algorithms, you will soon realize that solving dynamic programming problems is very easy and also fun. The objectives of this course are: understand the theory behind dynamic programming and related concepts in detail, learn about recursion and backtracking with detailed examples, and you will also learn why recursion and backtracking are important for dynamic programming. You will learn a step-by-step approach to come up with efficient solutions to any dynamic programming problem, even if you have not seen that problem before, with detailed explanation for around 15 important dynamic programming problems. Learn how to analyze the time and space complexities of different solutions, both naive recursive solution as well as optimized dynamic programming solutions. Also, you will learn some tricks to optimize the time and space complexity of the dynamic programming solutions further.